So step 1 tells me write the equation in standard form. Standard form is y prime plus f of x function y equals g of x. So I copy over here. So this equation, I have the 3x in front of y prime. I don't have anything here. So let's do a rearrangement by dividing the whole equation by 3x, 3x, 3x. Then I have y prime equal to plus, you can write y over 3 over x, or this is the same thing as 1 over 3xy. 3's cancel out, so I have 4x. Now there is a reason why I left it as 1 over 3xy rather than y over 3x, because if you look at this one, it's a multiplying of two things and then y alone. So we want to put exactly like this one. So that's my step 1. Step 1, I'm done. I rewrote my equation into a standard form. So I'm going to color code it so that you can follow along. Y prime right over here. F of x will be my 1/3 x, y, and then on the right hand side you have g of x. Okay. All right, step 2. We need to find the integrating factor right over here. That's the formula for the integrating factor. I of x is e raised to the integral of f of x dx. So my f of x is the purple term 1/3, 1 over 3x. So this will be equal to e raised to the 1 over 3x dx. Now, you can use it on the scratch paper to integrate 1 over 3x. 1/3 is a constant, so you can pull that out. So this is ln of x, so we have 1/3 ln x. So I of x is equal to e. This part is 1/3 ln x. Now, technically, we do have plus c. However, we are going to choose 0 for the constant of integration, so it's easier. So I have, in other words, the c will be always the constant when we are doing a integrating factor. So we are not getting those extra terms. So we can do a little bit of a simplifying work. One of the rules says you can move this 1/3 as a power. So I can rewrite that as e raised to the ln x raised to the 1/3. So e and ln cancel out. So my integrating factor is x raised to the 1/3. So that's the term that I'm going to be multiplying into my general form. So step 3, we are going to multiply both sides of the standard form by the integrating factor. So y prime plus 1/3 xy whole thing multiplied by the integrating factor. And then on the right hand side we have 4x. Then we're going to multiply by 1/3. So let's distribute. I'm going to have x of 1/3 y prime plus, now over here you have 1/3. This x really is a 3 over 3, right? Oh, actually it's 1 over 3x, not 1. Should be, let's rewrite it, 1 over 3x. So I'm going to have 1/3 x raised to the negative 2/3 if I distribute. 1/3 x raised to negative 2/3 y. And then on the right hand side, we are gonna have, this is 3 over 3, so we add, so 4x raised to the 4/3. Okay. Now, we are going to rewrite this. This is going to be reduced down to always the integrating factor times the y whole thing to the prime. So this is the trick and observation that I want you to see. Well, our integrating factor was 1/3. So it will be x raised to the 1/3 y whole thing prime equal to 4x 4/3. This is basically a product rule. So once you multiply the equation, the standard equation by the integrating factor, you're always going to get that product rule. That's the fact. So take a look, really quickly checking if you integrated this one by product rule, first one derivative of a second, so that's the first term. Now derivative of first term, 1/3 comes down, and then you subtract 3/3, so you get 2/3, and then multiply by the second term. So they are product rule of each other. So you can always write that as a product rule. Now step 4, we are going to integrate it both sides. So here was my step 3. The multiplying by the integrating factor, and then step 4, and then step 5. If I integrated both sides, this integration with the y prime disappears, so I have nicely, they kind of cancel each other. X raised to 1/3 y. On the right hand side, you can take out the 4, and then you raise power divided by new power. So it's going to be 7/3. So I'm going to multiply by 3/7. X raised to 7/3 plus c. So I have x 1/3 y is equal to 12/7. X to the 7/3 plus c. In order to have y by itself, I'm going to divide it by 1/3 divided by x to the 1/3. So y is equal to this one of the first term. I have 12/7. Subtract the exponent x raised to 6/3, because 7/3 subtract 1/3 is 6/3. So x raised to the second power. And then same thing, plus c divided by x to the 1/3. So that will be my final answer. We solve for y. Okay. So we'll do that two more time. Okay. So you get the idea and you feel comfortable. So when evaluating this part, we will use arbitrary constant. Here, when we do integrating factor, we'll choose 0 for the constant. Okay. So let's move on to one more. This time, we are going to find a particular solution because they give you the initial condition. So we are going to do exactly the same thing, but we are going to solve for C as well. So here, we have, this is our general formula written. And you can see that they are matching this time, so I don't have to do any work. Y prime, y prime. So my f of x will be 4x. And then you have y, and then right hand side will be my g of x. So your equation is already in a standard form. So let's figure out step 2, our integrating factor. It will be e raised to the f of x dx. My f of x is 4x. So e raised to the 4x dx. So antiderivative of 4x is 2x squared. And my constant will be 0. So my integrating factor is e raised to the 2x squared. So I'm gonna multiply the entire equation by our integrating factor. So you would end up having e times 2x squared times y prime plus 4xy. And then you have 8x times e raised to the 2x squared. Now if I distribute this one, I end up getting e raised to the 2x squared y prime. And then you have e to the 2x squared of 4x. I just do the rearrangement of y is equal to 8x e raised to the 2x squared. Now, this one is our product rule. You can see two things being multiplied, right? And then they switch around. So this one times the second one. And then the derivative of a first term times the second function. So this always will be in this form, ixy prime. So our equation will end up being integrating factor, so e to the 2x squared y whole thing prime. And you can check. This is the first term, and derivative of this by the chain rule, you get that 4 e to the 2x squared, and then the y term is attached. On the right hand side still remains the same, 8x e raised to the 2x squared. Let's antiderivative each side. Then you have e raised to the 2x squared y. On the right hand side, you can do u substitution. Let's say 2x squared. Then my du will be 4x dx. So my dx will be 1 over 4x du. Okay. So over here, I'm going to end up having 8x, I forgot dx. Should have a dx because everything is variable x. This part is u. Dx will be 1/4 x du. Now canceling out the x, 4 goes here into twice. This can be rewritten as 2eu du. So e raised to the 2x squared y. I'm going to end up having 2e to the u plus c. So e to the 2x squared y is equal to 2 times e raised to, substitute u back, 2x squared plus c. Now, I'm going to take this one, divide the entire side by e to the 2x squared. So let's do that to solve for y. Divide each side by e to the 2x squared, divided by e to the 2x squared. Divided by e to the 2x squared. Then I have y is equal to, they cancel out nicely. So 2 plus this part, I can rewrite that using the negative exponents, correct? Okay, so this will be general solution, but we are given the initial condition y sub 0 equal 3. In other words, we have a 0, 3. So let's plug it in to solve for c. My x is 0, y is 3. So that's 3 is equal to 2 plus c e raised to the negative 2 times the 0 square. So 3 is equal to 2 plus c e raised to 0, because this part is 0. In other words, anything raised to the 0 power is 1. So I have 3 is equal to 2 plus c. Subtract 2, I'm going to end up having c as a 1. So in other words, my particular solution will end up being y is equal to 2 plus c is 1. So e raised to the negative 2x squared will be my final answer. Okay. One more. This time we are going to work on an application problem. So we will come up with our equation and then solve by integrating factor. So let's read it through. An initial deposit of 10,000 is made into the account earning 4% compound continuously. Money is then continuously withdrawn at a constant rate of 500 per year until the account is depleted. So we have a couple things. The money is withdrawn at a rate. You see the constant rate. In other words, when we talk about the rate, that's a derivative function. At a $500 per year. So subtracting. Find the amount of account at any time t when will the amount be $0? What is the total amount withdraw from the account? So let's write out our equation. So we are given the rate. Now let's just label A as an amount in the account. Okay, and then T represent the time. Okay, so how long it was there. We'll do it in year because they give it rate as a in year. So my rate is DADT because that's your derivative. Okay, now you have, think about this. It's not, you have some gaining. You have the earning. How much? 4% of whatever you have. So we have 0.04 of the amount gaining, so positive, but after you gain, you get 500 taken out per year. Okay, so this will be my rate function total. Not just take away 500. We have an earning of 4% of what how much amount we have, but 500 is taken out. So that's good. So we have a function. Now I'm going to put this one over here so I can write it. So this part is like our derivative function, dy dx, but we have dA dt. So let's do arrangement. So I'm going to be adding, subtracting 0.04a, subtracting 0.04a. So we have dA dt subtract 0.04a equals negative 500. Now we have a function written in standard form. Your equation f of x is your negative 0.04. Your y is like your a, and then your g of x is negative 500. So let's find out our integrating factor. I'm just gonna use t because our variable is t now, not x. So that will be e raised to the f of t. So f of t dt. So my integrating factor is e raised to the negative 0.04 dt. So this one will be e raised to, this is an easy antiderivative. I'm going to have negative 0.04 t. So I'm going to multiply entire equation by my integrating factor. So we have e raised to negative 0.04 t multiply dA dt minus 0.04a equal to negative 500. Distributing, I'm going to have e raised to negative 0.04 t dA dt minus 0.04 e raised to negative 0.04 ta equal to negative 500 e raised to the negative 0.04 t. This part is your product rule of inner grading factor times the a function. So I have e raised to the negative 0.04 t times a whole thing prime. On the right hand side, you have negative 500 e raised to the negative 0.04 t. Let's take antiderivative, then the derivative and antiderivative cancels out. So you have e raised to the negative 0.04 ta. This part over here, you're going to do use substitution of negative 0.04 t. Then my du will be negative 0.04 dt. So I'm going to let you do use substitution. You should at the end have 12,500 e raised to the negative 0.04 t plus c after you are doing the use substitution. I'm going to divide it by each side by e raised to the negative 0.04 t. So we are having a by itself. So let's do that on the next page. Divide whole thing by e raised to negative 0.04 t. Divide each side by e raised to negative 0.04 t, e raised to the negative 0.04 t. So a function end up being 12,500 plus c. I'm going to put it into a positive exponent 0.04 t. So that will be my a function. This is your general solution. However, what they want you to find, let's go back and read it. So they want you to find a total amount and then when will the money be $0. So we have to know C. We haven't used this on our initial value. That means A at time 0, our A value is 10,000. So I'm going to be using that to substitute to solve for C. So I'm plugging in 0 times 10,000 onto this. So I have this one is a time and this is amount of money. So I have 10,000 is equal to 12,500 plus C times E raised to 0.04 times 0. So 10,000, 12,500 plus C E raised to the 0 power, another word, just the C. So subtract 12,500, subtract 12,500. C ended up being negative 2,500. So plug it in, my particular solution will be 12,500 minus 2,500 for C. Right? This will be what it's replaced. E raised to 0.04 t. Okay, to find when the account will have a balance of 0, that's the first question. That means my A is 0. We are solving for t. So let's write a sentence. So this is the first question answer to find when the account will have a balance of 0. Let A equal to 0 and solve the resulting equation. So let's plug it in. So 0 is equal to 12,500 minus 2,500 e raised to 0.04t. Subtract 12,500, subtract 12,500. Negative 12,500 is equal to negative 2,500 e raised to 0.04t divided by negative 2,500 divided by negative 2,500. I'm going to have, let's see, positive 5 on the left hand side is equal to e raised to 0.04t. So I'm going to apply ln both sides to get rid of it. So ln of 5, ln of e raised to 0.04t. So they cancel out. So ln of 5 is equal to 0.04t divided by 0.04 divided by 0.04. T will end up getting ln of 5 divided by 0.04. That is approximately in a decimal point about 40.24 years. So it takes 40 years, slightly over 40 years to have a balance of $0. Okay. So, but second part is, what is the total amount withdraw from this account? Let me make a room. Okay. So the second question is, the account will be depleted about 40.24 years and total withdrawn from the account will be that 40.24 times 500 because it withdraws 500 each, right? So 40.24 times 500 will be $20,120. That will be the total withdrawal from the account. Okay, that's it for section 9.3, and that is the end of chapter 9.